Day I thought that it's only English, only Polish-speaking people, but now we know that we have more people also from and other European countries. So we switch to English. So if you don't mind, please be active and answer my questions on the chat, because your activity I will put on the list later. So it's quite important to answer not only verbally, but also writing answers in the chat. So we just wait for a moment and we start 7:30 in the moment. So maybe I start with the short movie, because still we are waiting for some people. I will try to find the report, European drug report from the last year. Can you see European drug report?
Yes, we see.
Okay, so let's start again. Good morning, and please write down your name and surname as attendant, please. And yeah, regarding the first seminar, I sent you email with the slides, and also I ask you to yeah, if you wish, if you would like to have 1 hour for a discussion, I can also arrange with you and plan with you 1 hour for discussion, for consultation. It's up to you. Just send me your proposal for a date and time. And today we talk about the basic of forensic toxicology. And from time to time, maybe I will show you some short movie just to have a more different activity. Have you got any questions, maybe? Can we start? No question?
By attendance list, you mean we should write our names on the chat like last time?
Yes, I mean, yeah, name and surname, it's enough for me. And yeah, this is just for it's paperwork. I need it later.
Okay.
And also please write down answers for questions. Also, I will add some activity to the attendance list. So be nice if you answer questions. Okay, so let's start. If you have no question, so if you look at the first slide, you see the well-known well-known Paracelsus, and he's the first big toxicologist. He said that all substances are poisons, possible poisons, and there is none which is not a poison. So the dose differentiates a poison and the remedy. And of course, this is well known. And also, I put on the first on the list dose. Sometimes it's a mass, sometimes it's a volume of the substance, of pure substance, or just mixture. If you emphasize some other factors influencing pharmacological impact or toxicological impact, what you will put on the list instead of dose? What other factors? Just speak loudly and also write on the chat. It will be nice. So we have, of course, many different factors influencing toxicity and pharmacological impact, but yeah, maybe you just put some factors, some indicators. Okay, I just have a look on the, yeah, somebody, Elisabetta put purity of the substance. Of course, it's important purity, but it's more related to these impurities, which sometimes is toxic. But just more obvious, if you look at the internet and just try to buy some drugs, narcotic drugs, you will find information about details about dose of the drug, and also what is the quite important if you know dose. Concentration also is related to dose. Of course, you can give many different factors, and I will tell you in a moment about this. But the second, quite very important, it's also related to medical drugs, not only narcotic drugs. Time of metabolism. But okay, maybe I just wait for a moment. Reactions with other substances, so interactions, okay. Price, of course, frequency. of taking it also, but just yeah, imagine that you bought it in the internet, and the second step will be what? You know, dose and what? Yes, way of administration. Yeah, so type of administration. So we have the different routes. We have the oral route, we have the inhalation, injection. So this is very important route of administration. Okay, so the second paragraph is maybe not so related to toxicology, but if you look at the the content of this paragraph, all is interrelated, heaven and earth, air and water, where they are not together is only incomplete piece. So here I just put this paragraph because I like it. It's related to cooperation, collaboration. So we need more information from police, from prosecutor, and to have a bigger view of the circumstances. So it's very important to cooperate in different cases. Of course, if you look at the poison as a definition, it's a substance that causes intoxication, but we know that it's usually a small amount, not so huge amount. A small amount which after absorption into the body or produced into the body causes disturbances in the function or even death. But the production of the toxicity, production of the toxic substance, how can we produce more toxic substance? How it's possible to produce more toxicity? Using substance that accumulate in body. Okay, it's also important, but yeah, sometimes it happens. We have the different properties, lipophilic, hydrophilic. So lipophilic substances can have property of accumulation. But if you look at the way of metabolism, type of metabolism, is it possible to have more toxic metabolites than parent substance? So last week we talked about ethanol and some other aliphatic alcohols. So if you look at the ethanol, if you look at the alcohol, ethyl alcohol, the toxicity is more related to parent ethanol or metabolites like acetic aldehyde or acetic acid. What is more toxic? Parent substance or metabolites? Metabolites. So it's possible to have, of course, a production of the toxicity. But also, if you look at the Wilson disease, in Wilson disease, we expected higher level of concentration of cupric ions, and these cupric ions can create toxic situation, toxic impact on our organism. So also some kinds of diseases can create toxicity. Of course, these different definitions, forensic toxicology, if you look at this part of the science, we know that it's quite applicable science. So we try to answer to questions that may arise during investigations or judicial proceedings. So in fact, we use science to answer questions in forensic toxicology. Toxin is more narrow definition, it's natural in origin, so zootoxins or phytotoxin, it's more related to toxin definition. And toxic substance is also quite close to poison, so natural or synthetic original poison, and chemically defined. I didn't put on this list cyanobiotics. Cyanobiotics, it's substances that are different from natural, or sometimes different from natural level of concentration. Oops, sorry. So if you look at the toxic different factors, we talk about the dose. So it's here toxicity, acute toxicity related to lethal dose 50. It means that this dose create toxic influence on the species. Here we've got mice, rats, and this dose kill and create this death effect with different doses in milligram per kilogram of body weight. So on the top of this list, we have the natrium chlorine or aspirin. This is the most or the least toxic on the top. Yeah, here on the top. Of course, we have the least toxic substances. So on the bottom, we have the botulin, ED or dioxins, which is the very small LD50 dose, which is the most toxic. Sometimes, if you look at the amygdal, which you can find in seeds, in almonds, amygdal, we have the 300 LD50 dose. During the metabolism, via metabolism, we reach the cyanides. So cyanides is quite toxic. So during metabolism, we create more toxic environment. Okay, so another factors influencing toxic effect or even death, it's a Haber's law. It's quite easy to remember a law because it's a multiplication of concentration of the substances in the air and time of exposure. So lethal effect, it represents lethal effect with the non-linear dependency. So, for example, with concentration 1, we have the, for example, carbon monoxide, and with very high level of concentration, and during the fire, people die in very quick way in several minutes. And the same carbon monoxide with C2, concentration C2, we reach, let's say, the lethal effect on the red line in the level of concentration quite low, but in several hours or some hours. And it's also happen, for example, when we have the not working properly combustion apparatus for propane, butane in flats. So also whole families die with relatively low level of carbon monoxide in flats. So also happens death. If you look at the first example with C1 carbon monoxide and high concentration of carbon monoxide, if you try to think about the fire, what other factors influencing death during the fire? What other factors? Not only related to toxicity. So high temperature, yeah, and burning of our roots. I mean, exhausted root. Of course, lack of oxygen, very important factor. Lack of oxygen, so asphyxia related toxic effect. Yeah, also some other gases like cyanide, hydrogen cyanide, also some other pyrolytic gases inside, also carbon dioxide instead of carbon monoxide. Carbon dioxide, of course, it's less toxic, but still is not so, let's say, inert gas for us. So it's a more complex factors influencing death during the fire, not only carbon monoxide. So toxicity, it's going up with the also the number of atoms of chlorine. If you look at the acetic acid on the left and 3-chlorine acetic acid, we expected higher toxicity from this 3-chlorine acetic acid. So it's stronger acid, but also more toxic. So if you look at the chlorine, fluorine, or also bromium atoms, we expected higher toxicity, but also higher lipophilic property of the substances. Also in the direction to fluorine, we expected higher toxic effect. Sometimes it's related to the structure and also the position in the ring, the same substitutes. So with the same substitutes in position ortho, meta, or para substitute, we expected higher toxicity related to para position. It's, for example, true for paramethoxyamphetamine or paramethoxymethamphetamine. These two analogs of amphetamine and methamphetamine is more toxic than other analogs of amphetamine and methamphetamine. I told you about the pathway of administration as the second very important factor of toxicity instead of dose. Ingestion, inhalation, we have also the dermal route. If you look at the different pathway of administration, what do you think? What is the highest impact of the administration, of the toxicity via administration? What type of administration? The fastest, the highest? Yes, exactly, injection. Injection, so it's the fastest and the highest impact on toxicity or pharmacological impact. And on the other hand, we have, let's say, the smallest impact. What will be the smallest impact? Which route? Yes, applied to skin. Skin, we can talk about the skin as the smallest usually impact. So if you would like to have the longer in time liberation of the substance, its skin is okay. But if you look at the ingestion is somewhere between. Yeah, ingestion is somewhere between because the via evolution we are prepared to eat different stuff, and this intoxicated process is quite well prepared in human body. Time of exposure, so a brief encounter, long term, number of exposure, single dose, multiple doses over time. Also physical form, so solid, liquid, gas. If you look at the mercury, it's a very toxic as a gas, as a vapor. And mercury in the past, it was in many thermometers, and now it's forbidden in the EU, in the European Union countries to use mercury thermometers. So it's maybe less contact with mercury. Also genetic makeup, of course. Also gender, sex. If you look at the gender, we've seen last week, I told you about the difference in human body, I mean, women and men body related to volume of distribution. And we know that it's a higher concentration of the same dose for women than for men. And faster distribution, faster also elimination is related to women more than for men. So of course, gender has a huge impact. Also the age of the person, so very small children, infants, and also very old people are more sensitive for toxic substances and toxins. And Sometimes some diseases have also effect on the toxic impact. So we have many factors influencing toxicity. Okay, so from time to time, I will put you the result from the newest European Monitoring Center of Drug Addiction from Lisbon, the newest report from 2021. So here, if you look at the injection, if you look at the injection drug use, most recent and prevalence of injection in the drug in last year, and main drug injection in the EU, you see that in some countries they use injection like from Estonia, Latvia, Czechia, Lithuania, France for fentanyl and opioids, so mainly heroin. So these substances is of course quite toxic and influencing death much more than other narcotic drugs. Also, if you look at the this picture, you see that it's here that say we have the we have the tendency in between 2013 and now 2019 with heroin, methamphetamine, cocaine, and amphetamine, and we see that it's lowering, decreasing tendency in time, so which is okay, which is of course better situation now than several years ago with injection route for heroin, especially for heroin, but also for other drugs. Okay, let's back to the more general stuff. So of course, when we talk about the different toxic substances in our lab and many other labs, toxicological labs in the world, we analyze biological material, so biological fluids, mainly blood and urine, and we compare our result with reference concentrations. These reference concentrations we can find in literature, we can find in papers. So we have the some quite big book with information about the therapeutical, toxic, non-toxic, lethal concentration. So usually we have the ranges, not just one specific concentration, but just ranges for therapeutic, toxic, or lethal impact. And in many times they are overlapped. We have the overlapped ranges, so it's not so easy to interpret results. And organism growth, of course, sometimes we need, let's say, therapeutical for medical drugs. And when you cross the therapeutical range, we start with toxic effect or even lethal effect, and organism died. So we know over 13 million. Nowadays we can, let's say, even put here 20 million of known compounds, and around 100,000 has toxicological impact and significance. First on the list we can put these compounds with the gases. So carbon monoxide, cyanides, it's around 30 compounds. And in the brackets, I put gas chromatography as a method which we use more common. Second group, it's very close to the first one. So volatile substances, mainly it's related to petroleum. So it's toluene, it's also the xylans, and we have the alcohols here. So it's around 120 compounds, mainly gas chromatography related to mass spectrometry. Another group, it's of course here drugs and medicines. It's around 1,000, but we should add here around 800 new drugs, new psychoactive substances, which is also monitoring in the European countries. So in the drugs and medicines, usually we use immunoassays at the beginning, and we use liquid gas chromatography, also coupled, connected with tandem mass spectrometry. So in each toxicological lab, you can find mass spectrometry and more, because it's nowadays the most reliable, selective and specific method for identification, but also quantification of the substances. Metals, it's another group with around 20 compounds: arsenium, lead, thallium, also ferric ions, cupric ions. So we have the more old-fashioned kind of toxicity, and different apparatus. We use different equipment, so atomic absorption, atomic emission spectrometry, and also ICP-MS with mass spectrometry and argon plasma, quite new one, which we can analyze many metals at the one analytical method or analysis. Pesticides. Pesticides is a quite huge group, around 1,000 compounds. Again, similar techniques, so gas liquid chromatography with mass spectrometry. But if you look at the pesticides, what kind of job is related to use pesticides? Who uses pesticides? What profession? Of course, agriculture. So we expect it from farmers, but also who? Farmers and gardeners also, yeah? So we have these two groups, quite huge group related to pesticides. So a criminal or suicide, homicide, intoxication, it's related to pesticides. But also if you look at other profession like medical doctors or veterinaries, vets, for example, vets has an easy access to some barbiturates, so phenobarbital. Some suicides are in our lab, which we measure and detect, analyze samples. We also detect barbiturates in the suicide cases with veterinaries, with vets. Anions, it's more related to acids, so nitrates, phosphates, sulfates. It's quite seldom poisoning. Natural toxins, also in Poland, it's not so common. So we have in Poland habit of picking up mushrooms. So alpha amanitin, we can measure in the mushroom poisoning. But of course, also it depends on the country. In Poland, we still have the habit to pick up mushrooms. So we still have this kind of poisoning. For other countries, especially Western countries, is maybe not so common. And the others, so for example, dioxins. But still, we are occupied with the alcohol and narcotic drugs. So that's why I have this seminar more. In this seminar, I'm more focusing on the narcotic drugs. Okay, so what is important if you look at the case investigation? So it's for sure important to have the information related to victims. So gender, name, age, weight, height, nationality, recent foreign travel. Maybe not it was the best information last year because we were closed in our flats, but now is again world is open, so it's also important, recent foreign travel. Medical history, so we have the diseases, alcoholic drug addiction history, date and time in normal health, illness, treatment, so symptoms, hospital analysis, and also we should we should collect the samples especially blood and urine. So for a victim alive or dead, we need at least blood and urine, which is the basic type of material which we ask in different cases. So yeah, it's important to have this kind of material, but sometimes vomits, also liver, also stomach content also help us to solve the problem or answer the question. Of course, it's important to collect information. So a few minutes talking with the investigating officer can save many hours in the lab. So I would recommend to call police or prosecutor and talk with them about the circumstances of the death or of the case. So roughly, I told you that we have the 6 groups: gases, volatile compounds, drugs, also metals, pesticides, anions. And in the group of gases, so just quickly scan these groups. In the group of gases, we expected symptoms like asphyxia, vomiting, so red skin color, especially in carbon monoxide or cyanide poisoning. But this classic pink skin color from carboxyhemoglobin is not always apparent. So be careful that it's not always we have that kind of symptoms or this kind of indicators. Occupation, I told you about the occupation, which is important. So sewers, metal treatment, this kind of chemical industry, also very important. The most important substance in the group of gases, of course, is carbon monoxide. And if you look at the reaction, chemical reaction or biochemical reaction, we know that it's carbon monoxide. It's a compound which bond very strong, 200 more stronger than oxygen. So this connection with hemoglobin very strong, but we can reverse this reaction. So if you have an excessive amount of oxygen, we can create again the natural state of oxyhemoglobin. So we expected 1, 2, 3% as a physiological concentration for carboxyhemoglobin, COHB. If you smoke cigarettes, we expected 10% of carboxyhemoglobin, but lethal concentration is above 50%. So above this concentration, we expected that people will die. In most cases, cyanide is self-indicating, but it's odor of bitter almonds. But it's not always the case with the almond odor. It can be, but it's not always the case. Second group, it's volatile compounds. It's related to abdominal pain with phenols, convulsions with glucose, delirium, drunken behavior. Also, you see the vomiting, and clinical history is related to alcoholism, volatile substance. But this type of intoxication we expected in children or teenagers. Also in this volatile compounds inhalation, it's more related to poorer countries when the drugs are very expensive. Young, maybe not young, but children or teenagers can smell different glues and volatile liquids, organic compounds. So, of course, special care is needed if the samples have been frozen. So during the method, when we use analytical method, we should allow to thaw, preferably in room temperature, in very slow way. So it's important to taking care about the frozen material in the case of the volatile compounds. So it's related to alcohols, but also the volatile organic hydrocarbons. So now we started with the drugs, and maybe in some minutes we have that, maybe we establish a small break. Have you got any questions maybe? Everything is clear, and you don't have any special, let's say, questions. So maybe I show you the very short movie related to the behavior, and just have a look in the moment for just a few seconds of the movie. Just a moment.
Yo, what's your name? What? What's your name?
Have you seen DXM?
Yes.
Come on, it's something. Is my computer?
Yo, what's your name? What? What's your name? Mark. What are you doing here? I'm trying. What you take? I'm trying to sell businesses. How many you sold? I sold all. How many fingers I have? How many fingers? How many fingers? How many fingers? You alright, man? Yes, look alright. Nah, it doesn't. Fucking DXM. Yo, what? DXM is gonna fucking make me crazy. What's the matter with you, kid? You fucked up. What's wrong with today? Hey, that's the question. Answer the question. What's the question? Because you like slurring your words and shit. What's the question? Dude, I can't bring you home like this. What? Your 3 shades are fucked up right now. Fucking.
Okay, so you see that this guy is maybe not in the best way, in the best condition. So sometimes, okay, one moment. Can you see again the slides? Okay, so you see that, of course, unusual behavior, like in this movie, it was quite obvious. So slurred speech, this inappropriate answers to simple questions. So it was quite a good example of the inappropriate answers to simple questions. If you look at this kind of the type of behavior, it is quite, of course, obvious. Do you know DXM? What was the DXM? It's also a medical drug, dextromethorphan, DXM. Have you heard about DXM? So it's a anti-coughing, yeah, anti-coughing drug, medical drug with a opioid group. So sometimes the young people overdose the XN, dextromethorphan. Okay, so flat, dull, excited behavior, so unusual large or small pupils, unusual eye movements. Also, we look at this kind of symptoms in impairment of motor skills, which are also we'll mention later. So if you look at the European Union scale, we expected that people can die sometimes, and it's more related to the older people. If you look at the bottom here, I mean, if you look at the right bottom, number of drug-induced death reported in the EU between 2012 and 2019, you see the tendency in the older group, increasing tendency. If you look at the younger people, this darker blue, we see that young people have the decreasing tendency. So we have the older age of death, age at death. So it's 42 years, mean age of death at death. Also, if you look at here, also it's related to higher age, and tendency is in EU countries also is going up. If you look at the trends in overdose death, so it's not better situation. It's rather more and more danger, and the problem is more complex. Of course, if we look at the eyes and the size of the pupil, we have, let's say, dilated, so higher than 6 millimeters, 6.5 millimeters. We have the usually this kind of substance like cocaine, amphetamine. So we can talk about the stimulants or depressants. What kind of the substances? Stimulants or depressants? Have the dilated pupil. Cocaine, amphetamine, synthetic cathinones, that kind of substances. Yes, it's stimulants, yes. So also, of course, atropine, ephedrine. If you look at the constricted, less than 3 millimeters, very small pupil, size of the pupil, we have the if you look at these opiates, benzodiazepines, barbiturates, we have the let's say here depressants, but also we see here organophosphate, pesticides. Also, if you look, marijuana, it's on the first and the second group. Marijuana is not so characteristic. So at the beginning, usually people has a higher dilated size of the pupil, later can be constricted. And maybe for marijuana, it's more characteristic blood vessels in the eyes. So we have this kind of characteristic symptom of marijuana smoking. Of course, this symptoms chart, we put not only pupil size for depressants, stimulants, and others, but also reaction to light. And we expected it doesn't matter, depressant or stimulants, slower reaction to light. So sometimes a policeman can take a torch and turn on light in the eyes and just see that the reaction is slower than normal. Pulse rate, it depends on the depressant, stimulants. Blood pressure also is different, depressant and stimulants. Body temperature, of course, for stimulants, we expected high temperature. And for example, amphetamine, methamphetamine, ecstasy, we expected high temperature. So sometimes we have the other indicators. So we have the uncoordinated restlessness is also quite characteristic. So of course, yeah, it also helps us to have the suspicious about the being under influence or not different substances. Of course, sometimes look of the person. This look before and after 4 months of amphetamine use here is maybe not so dramatic and so different. Sometimes students say that this picture, this photo of this man after 4 months is better than amphetamine before amphetamine use. But if you look at this woman, before and after 3.5 years of methamphetamine use, maybe it's quite strange and huge difference. So on the left, before taking methamphetamine, before methamphetamine use, we see women at her age. What age you will give this woman now on the left? In her 40s, maybe, yeah, 30s, 40s, yeah. And on the right, the same woman, we see the picture of woman at her maybe 50, 60, yeah. So we have the huge difference in look of the person, but the difference in time is not so huge. It's just 3.5 years. So we see huge impact. So of course, we usually don't see 2 pictures in time, in different time, but we can see the person and we know her age. So if the age doesn't match the look, it's just indicator, yeah. We have not so we have the imagination of the age of the person, and this imagination of the age, it doesn't suit to the look. So reduction in body weight, skin lesions, asymmetrical facial halves. So we have some symptoms in the look. Also destruction of teeth after methamphetamine use, and methamphetamine powders, methamphetamine, different kind of seizures. We expected, let's say, acidic environment, and this acidic environment creates huge impact on the destruction of teeth. Of course, we collect information about the drugs, background information. So were there any drugs in the possession of the victim or defendant? What was the subject's condition? Drowsy, asleep, confused, agitated? Did the police doctor certify impairment, driving ability? Was the subject prescribed any drugs by doctor? Or if so, when was the last dose taken? Is the subject a non-drug addict? So we collect this information just to have the bigger and better view of the situation. Of course, if you look at the drugs and this group of drugs, we have the quite different properties. So from opiates, we expected contracted pupils, muscle twitching, slow respiration, hypotension, coma. From stimulants like amphetamine, we expected dilated pupils, dry mouth, headache, tachycardia, tremors, convulsions. So different kinds of symptoms related to different drugs. Age, you see that this in this table we have the, let's say, quite old information, because between 16 and 30 years old people related to illicit drug use, it's maybe not more common nowadays. We know that it shifted in European Union countries to the older people. Scene also can be changed. So during the COVID-19 time, we expected not discos, clubs, but we expected the drug use in homes, and more than in clubs or discos, because they were closed. Additional investigations, so ante-mortem samples, sometimes it's we can collect them in the hospitals, and later we can also analyze or reanalyze, again analyze. Nasal swabs, maybe not so common. injection marks. During autopsy, our doctors can see injection marks. So if you look at the estimation of drug use in European countries for 2019 and 2020, we have the not so huge differences. Yeah, so just small details differentiate between 2019 and 2020 in the use of cannabis or in the use of cocaine. If you look at the 2020 report for the 2019 results, we have around 0.8% for MDMA, ecstasy, for amphetamine 0.6, and heroin. We see here that it's related to the fatal overdoses, 82%. So 1.3 million high-risk opioid users. So a year later, we have the also similar situation, 0.9% MDMA, 0.7 amphetamines, 76% of fatal overdoses, and around 1 million high-risk opioid users. So if you look at the year to year, it's not huge differences. But if you look at the later in tendency during the decade, so 10 years, we can see a huge differences. So for the last report, we see that the number of reported drugs seized in the EU, we have the cannabis on the top. So herbal cannabis, resin, it's a majority of the drug seizures. Cocaine, 11%, amphetamine, 5%. We have the heroin, 3%, MDMA, and the others. So, of course, in Poland, we think about the drugs and we know about cannabis, but on the second place we put amphetamine. But it's not true, generally speaking, in European countries, EU countries, because the more common drug is cocaine as a stimulant. You see, it's double than amphetamine. So if you look at the tendency between 2009 and 2019, you see that it's a more and more number of drug seizures in the European Union countries. Also, the quantity of drugs seized in European Union also is going up in the last years. So situation with the different drugs is different, but the tendency is increasing with especially MDMA, so ecstasy, methamphetamine. We have more and more this kind of substances, these stimulants. Also, herbal cannabis, it's relatively stable situation. Amphetamine, not so huge increasing tendency. So especially MDMA and methamphetamine, it's increasing last years. Okay, I think that we maybe establish small break. What do you think? 10 minutes? It's okay? Computer. So let's start with amphetamine and methamphetamine. If you look at the structure of the methamphetamine, it's not a huge difference. It's just a methylene group here connected to the nitrogen. And this methylene, creates more lipophilic properties of methamphetamine. So methamphetamine is stronger and give the higher affinity to lipophilic tissues, but also to our brain. So it's a higher impact on our brain. And main metabolic reaction is deamination to phenylacetone and later to benzoic acid and finally to form of hippuric acid. The lethal dose for non-addicted is 200 milligrams, and toxic effect may be produced with the blood concentration between 0.2 and 3, but fatalities is also not so high, it's 0.5. So we have the overlapped regions for toxic and fatal concentrations. So you see here that it's for reference concentrations for amphetamine, it's not so easy to interpret because it's overlapped ranges. And death from overdoses is relatively rare. So if you look at the picture of European Union countries, we see more or less quite normal picture with gender, so 75% men and 25% of women. So 3/4 of the gender is men, and usually it's a double more than women. And quite interesting, it's a way of administration, roof of administration. So it's really different. So, but sniffing is the most common route of administration, 65%. Eating, drinking, 16. Injection, smoking. So it's quite interesting. But also, if you look at the countries, we have Sweden, Poland, and some countries in this vertical line. If you look at the methamphetamine, it's a bit different if you look at the countries. So we have Czech or Slovakia countries, or Turkey, maybe more common than for other countries. A very similar characteristic with gender. Route of administration also quite close, but less sniffing, more injection maybe than before, smoking, inhalation, yeah, it's in different geographical pattern. And now I would like to give you the opportunity to calculate retrospective estimation. We've done a retrospective estimation for ethanol last week, and now it's a kind of the similar calculation, but with the amphetamine. Of course, we do this kind of calculation very seldom. In fact, it's very, very, very seldom. So because of the variability of pharmacokinetic parameters and lack of information about the circumstances of the case, we have the problem with the reliable calculation. But anyway, we try to do it with your help. And in the moment, I will give you some data to calculate it. So please take your mobile phones and enter and click on the calculator, because we will try to establish the estimate concentration at the moment of case. So Tx time, at Tx time, we will try to calculate concentration of amphetamine. But before calculation, I will just explain you here the data and the parameters here. So here it's a time of case. Ts, it's a time of sampling. In our case, it's a time of blood sampling. And of course, we need half-life of amphetamine. So if you look at this description, so please estimate the concentration of the amphetamine in the blood in retrospective calculation at the time of X, assuming the half-life of amphetamine in the body in the range between 9 and 12 hours. So we have two options, 9 and 12 hours, depending on urine pH. And for 9 hours, the first option, 9 hours, so will be for the acidic pH. 12 hours will be for basic pH. And so we have two options of this and two results we will reach. So yeah, we also need some more information about the not only half-life of amphetamine, but also the value for concentration at the moment of sampling. So I will give you this information to this formula. So CS, I put here the concentration, 130 nanograms per milliliter. And you know that, let's try TS, time of sampling. Let's take our time, 8:45. For example, let's ask about the TX, let's say 2 hours before. And you know that T half, it will be half half time for the amphetamine is 9 to 12 hours. So now you've got all the data to calculate concentration at the moment of case. Try to do it in the two options with the half-life 9 and half-life 12. Yes, if you just subtract TS minus TX, it's 2 hours. Yeah, so in the upper part of this formula, you've got the 2 divided by 9 or 2 divided by 12. So you can round it, this information, this calculation rounded concentration CX to only the constant, yeah, I mean not after dot values, so rounded to the whole number. So rounded, yeah, without digit after dots. Okay. Yes, please do it as much as possible. This is the moment for calculation. So we also here established, let's say, elimination phase. So we expected the decreasing tendency. So we expected higher concentration that 130. Okay. Okay, so I think it's okay results. So between 146 and 152 related to different acidic or basic environment of urine. So you see that it's a range, and we expected range in time because we don't know what was the urine, for example, pH. And the second question is that this driver, for example, was under influence of after use of the psychotropic substance of the amphetamine. Maybe you don't know, but in Poland we have some kind of the recommendations for being after use and under influence of amphetamine. And just for your information, you see that it's, I will put you maybe, if you have the results between 25 and 50 nanograms per milliliter of amphetamine, this ranges is for after use of amphetamine. If you have the above of 50 nanograms per milliliters, it's under influence. So in this case, we can interpret our results, what kind of the state it's after use or under influence of amphetamine. Yes, it's under influence, yeah, at the moment of sampling, but also at the moment of the case. So it's quite far away from the 50. It's limit for under influence. So yeah, we have no doubt about the being under influence of amphetamine. So more or less that kind of interpretation we prepare for prosecutor from time to time. I will be back to amphetamine maybe a bit later. If you look at the cannabis, we know that cannabis use people around 1% of European Union countries. Around 1% of population in EU also is related to alcohol. So we have nowadays a similar group in Poland and in many countries in Europe, smoking marijuana and drinking alcohol. Similar group of drivers. Of course, the delta-9 THC is the most psychoactive ingredient of cannabis, and with lipophilic lipophilic property, we expected very high bioaccumulation of delta 19-HC and cannabis substances in lipophilic tissues. And this is why we expected also longer time for detection of delta 9-THC. But the longer period window time of detection of delta 9-THC, you think it's more related to chronic or non-chronic users of marijuana? Maybe I should start with that we expected, for example, that we can detect substances, psychoactive substances within 24 hours, within 1 day or 2 days usually. But sometimes we can also detect substances, psychoactive substances for longer period, for 5 days, a week, or even 2 weeks, or even month. And in the case of cannabis, we expected longer period, I mean 1 week, 2 weeks, or even month for chronic or for non-chronic users of marijuana. Chronic users of marijuana is based on the daily base frequency. So if you smoke marijuana at least one per day, it's a chronic user. Yeah, chronic, definitely chronic, because of course at that time, at that moment, we have the possibility to accumulate delta 9-THC. Of course, delta 9-THC can affect loss in consciousness, but even death. But these reports with fatalities are quite seldom, and you can find just a few reports related to fatalities and delta 9-THC intoxication or cannabis intoxication. Cocaine is the most common stimulant in Europe, not amphetamine, but cocaine. And it's normally used in the surface anesthetic in the eye, ear, nose. But also we know that addicted people may inject it and use it as a snuff. And what is quite interesting that the main metabolites like benzoyloagonine or agonine methyl ester are inactive. So cocaine acts very quickly, and this psychoactive action is 15 minutes or half an hour, not longer. Other metabolites like ethyloglucuronide, ethyloagonine, hydrococaine also have been reported. Maybe you know one other metabolites. It's coca-ethylene. It's called coca-ethylene, which is created with the alcohol. So if you drink alcohol and take cocaine, it's possible to create coca-ethylene, which is psychoactive. So it's in many cases people who takes cocaine also drink alcohol to prolong action of cocaine. Heroin, as we know, this very dangerous and very toxic substance drug, and it's metabolized quite quickly to 6-monoacetylmorphine, which is specific for heroin use. So to heroin is related also the way of administration is very important. So heroin parent drug was found in oral up to 24 hours after having smoked and up to 60 minutes after injection. So if heroin is snorted or smoked, very high levels of heroin may be detected in oral fluid for several hours after use because of the deposition of the parent drug. It's very similar situation with the cannabis. So if you smoke cannabis, if you smoke marijuana, hashish marijuana, we expected also the longer detection of the positive results for the saliva. So for heroin, I talked before that it's decreasing tendency is used, so which is good. Between 2009 and 2019, we see that with different countries like France, Germany, Spain, Italy, we have the decreasing tendency, which is okay. But if you look at the spread and in gender, we expected also here quite huge difference in men and women. So mainly it's related to men intoxication and frequency. In the last month, we have just related to the addicted to heroin. So different countries have different pattern of drug use or drug addiction. So in Poland, we have if you look at the treatment entrance, we have of course, cannabis on the top, but the second position is amphetamines. And if you look at the overdose death, it's around 250. Here it's a decreasing tendency with the HIV diagnosis attributed to injection. And but it's also related to opioid, less and less opioid. If you look at Sweden, it's on the top, it's stimulants, but you see that of course cannabis is quite huge, but opioids 24%. It is green bar here for opioids, quite huge opioid users, and also overdose death. It's around 600 people. So if you compare with population of the Sweden, 6 million, and it's quite high related to Poland with 26 million of the population in that age between 15 and 64 age. And if you look at Spain, for example, we have the similar population like in Poland, and 390 overdose death. But yeah, quite characteristic for Spain, it's instead of cannabis, we have the huge number with the cocaine users, 37% of cocaine. So it's different. Of course, heroin also is quite huge impact with heroin, but cocaine on the top. So it's probably more related also to the connection with Latin America and smuggling from Latin America to Europe. It's maybe easier here, but of course cocaine is very expensive, still very expensive. So richer countries has the higher, better opportunity to spend money for cocaine related to poorer countries like in Poland. Okay, so we have also the new drugs, new psychoactive substances, NPS, drugs which are created to get around existing drug in the market, in the black market. We call them in different names, but of course, new drugs, it's the simplest name for that. The criminalists and the scientists who cooperate with criminalists, they use science, they use knowledge about the designing the drugs. So we have the structure similar to compounds, classical drugs, or act on the same receptors of the classical substances, like in classical substances. So structure-activity relationship is very important. And here we know that, for example, cannabis with CB1 or CB2 receptors is the same for natural cannabis, but also for synthetic cannabinoids. So new psychoactive substances in European Union countries in 2020, so last year it was 46. In several years before, I will show you in a moment, it was around even 100 per year. So now we have the huge number controlled, monitored, 830, and on the market each year around 400 new drugs. So number of substances for last year It was the same like in the 2 years ago. So it's on the top still cannabinoids, but synthetic cathinones. We see also here opioids, 67 opioids. We have the tryptamines, phenylethylamines, and the other number of substances monitoring by early warning system in EU. And this is the picture which I showed students for many years, and you see that this huge wave, we have the huge wave with the new drugs in 2014, 2015, which was around 100 new drugs per year. Now it's a decreasing tendency, and the last year, as I told you, it's around 40 new drugs per year. So of course it's okay. It's why it's changed this situation. Maybe you know what was the reason why people stopped a little bit with the new drugs. What do you think? What was the reason? Maybe you know. I mean, the highest you see, it's a 2014, 2015 year. So it was the biggest number of new drugs on the black market in EU. And so there is something happened. You told about the stopping in 28. I mean that it's some restrictions in European countries, in my eyes, they started in around 2014, 2015. In Poland, it was in 2018. There are some restrictions, and we introduced in Poland also the more strict law related to new drugs, but also in other countries, in Germany, in the UK, and some other countries, we have the more strict law introducing, and also in practice they were more difficult to introduce new drugs. So if you look at the different groups of new drugs like synthetic cannabinoids, also we see that synthetic cannabinoids is on the decreasing wave, decreasing tendency. Opioids, we still have the quite huge number, but you see that opioids it's maybe less and less, but fentanyl derivatives, fentanyl, it's still quite high, and year by year, last years, we have the fentanyls and other opioids. Sorry, fentanyls are less. Sorry. Fentanyls are less, but opioids still is increasing. So yeah, different substances is going up and down, but the last 2 years they are different than previous years. So we know that these numbers maybe is just a COVID-19 impact, and this COVID-19 influencing the new drugs. They are not so easy to buy it via internet. If you look at the risk assessment, I mean, this risk assessment is related to death, unfortunately to death. So if you look at the death and new psychoactive substances, so you see that in the group of synthetic cannabinoid, you have MDMB, Pinaka, and 9 deaths in Hungary or in Sweden. We have also synthetic cannabinoid in 2020, 4F, MDMB, Bika, 21 deaths in Hungary again. So isothiocyanine, non-fentanyl, but benzimidazole opioid. So we have also quite huge number, 22 deaths reported up to 2019. So we have, let's say, very harmful synthetic opioids, but also synthetic cannabinoids. So low psychoactive dose also it's a problem, because it's very easy to overdoses if you have the small psychoactive dose. So structure of NPS, we can, here emphasizes just a few of these structures. In fact, we have around 10 structures of new drugs. On the top of this picture, you see phenylethylamines, amphetamines, or synthetic cathinones. But of course, also we have the huge number of other. Mainly, we have the nitrogen organic compounds. So kind of, let's say, here mention structures. So one of the simplest structure is phenylethylamine structure. And this structure of phenylethylamine, we can see this amine in the case of the amphetamine, methamphetamine, but also this structure you can find for dopamine, adrenaline, and norepinephrine. So it's a natural psychoactive substances with a hydroxy group if you compare with phenylethylamine structure, and we know that they are psychoactive also. And one of the new drug group, it's a C2 group, which is quite old one. We can't find it nowadays, C2 group substances, but in the past it was quite common. So we have the, based on the phenylethylamine structure with methoxy groups and some substitutes in the ring, with mainly with the bromium, chlorine or iode, and some also aliphatic groups you can find with the other C2 group new drugs. Sometimes it's not similarity to the structure, but similarity with the receptors. So quite old one, GWH018, synthetic cannabinoid, has not so huge similarity to delta-9 THC, natural delta-9 THC, but they act on the same receptors, CB1 and CB2 cannabinoid receptors. So it's, of course, many times similarity to structure and similarity with the action to receptors. So this kind of the new drugs usually are sold in very nice, colorful packages. And this is the organic car perfume. It was sold in Germany. And inside of this package, we can find the synthetic cannabinoid AM2232. And usually, of course, they warning us with the product only for adults, so above 18 years old people. Okay, so I've finished with the group drugs for a moment, and just add some information about the metals. Of course, with the metals in the group 4, we expected quite different symptoms of metallic taste, paralysis, salivation, vomiting, weight loss. Also symptoms maybe here not so strange, but it's usually within 24 hours. And occupation, it's more chemical or electroplating. Pesticides, we talked about the profession. We know that it's more related to, but the sunlight, it's too much for me. So chlorinated organophosphate, different symptoms, and we know that it's around 1,000 compounds related to pesticides. So we know that it's quite different properties for this kind of substances. So usually it's a rapid, but also it's possible to have the longer period for the symptoms. Sometimes possible to analyze and detect solvent inside of the pesticides. We have some additional substances to provide better distribution in the environment. So we have sometimes solvents. So sometimes during the routine analysis, we can find, I don't know, toluene or some organic solvents. And after we can also measure pesticides. Occupation, I told you about workers, gardeners. The sixth group is poisons anions, but in that case we have the quite huge toxic dose. It's above usually 10 grams, so it's a quite huge. And symptoms: abdominal pain, cyanosis, methemoglobin formed with oxidizing agents like permanganates, oxalate, bleaching agents. Okay, and now maybe we switch to the examination and analytical toxicology, but maybe I show you before the switching to this subject a short movie related to gender and drugs, and I think it's quite interesting to have this discrepancy between men and women. Just a moment.
In Europe, around 37 million women have used an illicit drug.
Okay, one moment. Okay, can you see it?
In Europe, around 37 million women have used an illicit drug at least once in their lifetime. Around 100,000 women enter drug treatment every year. Nearly 2,000 die from drug overdose. Over the last decade, the gender gap has been narrowing among young school students who use drugs.
Women represent only a fifth of clients in specialized drug treatment, but their problems are often more complex than for men. They tend to progress faster towards addiction, a phenomenon known as telescoping. They go through more severe withdrawal symptoms and report higher levels of depression and anxiety.
Women often start using drugs through a drug-using male partner and are more likely to share needles and other equipment with their partner. In general, women are likely to have fewer socioeconomic resources. This is even more the case for women who use drugs. They experience more stigma because they may be perceived as contravening their roles as mother and caregiver.
Some groups of women have specific needs, such as pregnant and parenting women, women from ethnic minorities, women in prison, and those involved in sex work. A specific drug-related issue for women is intimate violence and drug-facilitated sexual assault, which has serious psychological and social consequences. Services for women with drug use problems need to address these unique concerns. They need to be welcoming, non-judgmental, supportive, and physically and emotionally safe.
To achieve this, women who use drugs need to be fully involved in the planning and development of policies and services. The staff recruited in drug services need to have appropriate attitudes, knowledge, and skills. Services need to be well coordinated and integrated to address different issues such as mental health, pregnancy, and childcare. And monitoring and research needs to consider this gender dimension to optimize effective responses for women with drug-related problems.
Okay, just a short movie with discrepancy for women and for men. And of course, it's for women, it's a different problem because of the stigma and some other, or pregnancy, as you see, also is quite important. Okay, let's back to examination and analytical toxicology. Let's step with this kind of the steps in systematic toxicology analysis. If you look at the first sample preparation, we expected that in sample preparation we use some laboratory steps like hydrolysis, headspace, liquid, solid phase extraction. Later we use some simple color test, but also more developed and more advanced TLC, thin layer chromatography, gas chromatography, liquid chromatography with different detectors. And of course, nowadays we use more and more mass spectrometry or tandem mass spectrometry. And the last step in toxicological analysis, it's related to identification and compare results with the fingerprint of authentic compounds in the database, or with our compound which we injected before from our base, and we use these databases to interpret results. Another steps related to toxicological investigations, maybe it's even better approach, I mean pre-analytical. So we have the steps related to the poisoning circumstances, so poisoning episode, and we have the results from some other laboratories, medical history, occupation. As I told you before, this pre-analytical, it's very important, I told you also before. So analytical steps, which I mentioned just a few seconds ago, and the post-analytical steps, it's interpretation based on these previous steps. So looking after the patients or pathologists, and we have the information from steps before. So we know what was the patient history, medical history. We know the history of the sample, when was the sample taken, and based on this information, we try to answer the questions, and what I told you before. So we also should save our samples for possible future use, and sometimes some laboratories, they use completely material, and because they are afraid to reanalyze samples. So which of course it's not okay to do this from the point of view of from the moral point of view also. Okay, so these steps also we can split on the detection, just to detect the poison or the group of poisons in screening procedures. Identification is mainly related to the specific identification, selective identification with the more advanced method. Quantification with the usually the same method, but maybe sometimes it's different. For quality and quantity method, it's sometimes it's different. And also metabolites. Some metabolites are more specific than parent substances, and we also detect metabolites. And interpretation, based on the second and third step, we try to give the answer on the question. So of course, most of the forensic toxicology cases is quite typical. So we know that they act on the central nervous system. Also in Polish law, we are focusing on the central nervous system substances related to influencing on our brain. So alcohol, of course, some narcotic drugs like opioids, like amphetamines. Completely systematic and comprehensive scheme that covers all the poisons is extremely costly. So usually we don't have so much money to check and to detect all possible poisons. We should be focused on the most common, most likely group based on the circumstances of the case. So, for example, if you have the time of onset of the symptoms was less than 1 hour, and there is no evidence of injection material, for example, the sample should be examined for gases or volatile poisons before other groups. I had in the past one woman who committed suicide with the ethylene glycol, and she drank ethylene glycol, and we have no other symptoms of her death. But it's probably it was less than 1 hour of the intoxication. Severe vomiting and diarrhea indicate possible metal poisoning. age and occupation. I told you that teenagers indulge solvent or glue abusers. Pesticides are more related to gardeners or farmers. Cyanide with the electroplating factory workers. Of course, sometimes we have the possibility to take more than blood and urine, but blood and urine, it's the basic type of material. And the top, on the top, I put, blood, because we have possibility to detect parent compound, and we can interpret quantitatively and qualitatively this result. Of course, sometimes it's limited volume and low concentration of the substance. Urine, it's usually high concentrations of many poisons, but it's not so much related to the psychoactive action. So we have possibility to detect with longer, broader window time of detection, but this very difficult to connect with the state under influence of drugs. Of course, stomach content, it's very nice if you have the pieces of tablets, of capsules, of medicines, but of course, it's not always the case. It's sometimes happen. Saliva is non-invasive, but in that case, we can use the immunoassay saliva tests, which is quite quick. Within 5 minutes, we can have results for more typical common drugs or medicines. Hair nails as a material, it's okay because it's more or less not so difficult to take it, but from the point of view of checking the state under influence, it's not so easy to judge state under influence with hair or nails, because if you look at the rate of growth of hair, we expected what is the growth of hair? Speed of growth of hair. What do you think per month in centimeters? Growth rate. Maybe you know. It's around one centimeter. Yeah, it's around 1 centimeter per month with hair. Nails are even lower growth rate, so it's a quite slow growth rate, and of course in that case we expected quite low content of analytes, low content of substances, and not all substances can easily incorporate in the structure of hair or nails. So it's nice material, but it mainly used for chronic checking chronic users, not for the checking case, or for example, especially one day or one case, it's usually not detected by hair or nails analyzes. So thin residues, tablets, bottles, scans, of course, if you have the possibility to check it and to find it near the victim or in the area of the case. Vitreous humor, it's quite nice. Of course, it's taken from dead people and during autopsy, and may be used instead of urine. And analysis may be valuable to help interpret post-mortem blood data, especially if you have the degraded material. Additional tissues, liver, brain, lung, kidney, it's not so common to take because it's expensive, but also it depends on the case. So if you look at the lung, what do you think? When lung will be quite interesting and worth to take and to analyze taking the lung during autopsy? What kind of cases we expected that lung will be useful? what kind of intoxication we expected when we would like to analyze lung tissue. Smoking marijuana, maybe not, because smoking marijuana, especially marijuana, usually it's not related to death marijuana. So of course, smoking, it's a right direction. I mean, if you look at the poisons, volatile poisons, we expected that in the lung we can find some lipophilic substances. So, for example, toluene intoxication or like solvent intoxication, it's possible to check also lung. So yeah, it's a right direction. Kidney, we can use kidney instead of urine, for example. Liver, because of the metabolism related to liver. So yeah, it depends on the case. And we should, let's say, select related to the case circumstances. Of course, in practice, analyze, don't spend too much time, identify every tablet or capsule. And for example, we can take, of course, less than a whole number of seizures. So if you have the, for example, square root of the population size, which looks very, very similar, we can take for analysis, instead of 400 tablets, 20. So it's a square root from 400 tablets. Of course, we can use some other approach, 10% of population size. Also, it's possible, another approach, or hypergeometric sampling table, which is also quite nice because it's related to the number. Of course, if you analyze tablets and we have the not homogenized material and different tablet from tablet to tablet, we should take more tablets to check whole series. Of course, food or drink residues near the body help us to solve the problems, to solve or to answer the questions. Body fluids, at least 10 milliliters or 10 grams we need usually. Urine, of course, it helps us, especially with the screening test. Stomach content, especially when we have the this suspicion of oral route. Blood, of course, bright cherry color can indicate the carbon monoxide or cyanide poisoning. If you have a dark brown color of blood, maybe it's related to methemoglobinemia. So it's nitrates, for example, or aniline or chlorate poisoning. So color, different or just strange color of blood can indicate some unusual type of intoxication. I told you that we need around 10 meters or 10 grams of material, and also it's good to have that preserved sample. So preserved and unpreserved blood, it's okay, because if you have the fluoride and you kill bacterial action, we also helps with the right and proper detection of clonazepam, cocaine, and nitrazepam, because they can be degraded if we don't kill this bacterial action with fluoride. So for better estimation of the concentration is to take preserved and unpreserved blood samples for later analytical toxicological studies. Liver, of course, should be still requested as a routine specimen because of this liver metabolism. especially when we have homicidal, uncovered homicidal poisoning. Tissue analysis is also necessity for exhumed or decomposed bodies around 2-3 years after death. Yes, a question. The fluoride tubes means that it contains fluoride in the tube itself, or that it should be added to the sample. I mean, yeah, in most of the cases, fluoride is in the tube itself, and nobody added later. But of course, in the past, when we have that kind of tubes, it was the case that people add before storaging, they add also fluoride. But nowadays, in most of the cases, our doctors and in the hospitals, they add material for this purpose to preserve with fluoride tubes. So usually, it's prepared before. Sometimes the color of urine can indicate the possible cause of intoxication. So yellow-brown can indicate strange yellow-brown. It can indicate nitrobenzens. Red-brown, for example, let's say Congo red, warfarin. Blue-green could be from the copper salts. Blue-green, strange color of the urine. Black color of urine can be prepared by the blood contamination in the urine. So this contamination creates strange black color of urine. Also the smell, strange smell. So smell of almonds can indicate cyanides. I had 2 or 3, maybe 2 poisoning with the cyanides in my experience, in my laboratory here, and in each case I couldn't detect cyanide by smell. So it's maybe more related to, of course, medical doctors, and if you have in the stomach content cyanide, natrium cyanide or potassium cyanide, maybe it's possible to smell it with a high concentration. But you should be warned because of the cyanide, because a reaction of the cyanide with the hydrochloric acid, it's possible to have the prussic acid, so hydrogen cyanide gas, liberated in this reaction with stomach contact, and sometimes medical doctors during autopsy can inhalate hydrogen cyanide in the case of the people who committed suicide with cyanides. Of course, garlic from arsenic, phosphine, petrol from petroleum, but of course, in the most cases, the most common smell, it's a rotten egg. Rotten egg, it's related to the decayed biological materials. So this is the most common smell in the autopsy room during the autopsy. Orfila said many years ago that it's we need experience with this job. So chemists, biologists, pharmacologists, or doctors need experience. We need also a complete case history. Of course, it depends on the question. So it's not always the case that we know a complete case history, but it's nice to have this information. All the evidential material suitably labeled and sealed in clean containers must be submitted. Of course, identification of the material, it's the basic stuff. So if you have the not right labeled, it's useless material. All known identification tests should be applied. Maybe in Orfila time it's possible. Nowadays we have too many different methods, so we don't provide Orfila rule that we use all the known identification tests. We try to use the optimal method, and of course method which we can use in our laboratory with our equipment, the best which we can do it. All necessary reagents used for this test should be pure, and blank test should be performed. So blank test, of course, in each series of analysis, and also control tests, control samples with the poison, suspected in poison added to the one of the sample. Also, it's nice to have this kind of sample. So yeah, of course, blank test and control samples always we add to series of analysis. Of course, these screening methods, we use usually simple methods, immunochemical, but also simple chromatographical methods. And if you have negative should be reliable. We finish at that stage, but yeah, positive results we should check. So confirmation methods usually are more advanced, more selective, and for quantitative or qualitative results, we use these different, as I told you, chromatographic methods. I told you about the window of detection, and which is quite important to have the information about the timeline with detection. So if you look at this different material, we expected, for example, we expected for blood and saliva very similar time window of detection. So usually it's not longer than 1 day, so 24 hours with blood and saliva, just a few hours up to 24 hours. With urine, it's a longer time. It's even 2 days, 3 days. Sweat, also similar. Here is a picture for THC, delta-9 THC, parent substance, but it's also quite close to other substances also. So above 1 week, we expected also to find some marijuana THC or THCA compounds after 1 week, because we need this lag time for incorporation of the THC in the structure of the hair. So after 1 week, we can cut hair. It's not one piece of hair, but a branch of hair. A branch of hair, yeah, at least 50, 100 milligrams of hair for analysis. Of course, if you look at the historical methods like the thin layer chromatography, we see that this is not so easy to interpret this TLC, thin layer chromatography. On the left of this plate and on the right, we have the standards, so pure substances. And after put these substances on the start line, and later when we have the chromatographic results, we have the dots, different dots. But in the center of this plate, TLC plate, we have the biological material. So we have the here we've got the blood, urine, probably we've got the brain. We have here some biological material, and you see that these dots, which are originally comes from biological material, it's not so easy to interpret because it's overlap. They have better resolution, and also we can't see a small amount of substances. So TLC method is going to the history. We don't use for many years TLC because it's very low resolution and lack of sensitivity. So nowadays we use in Poland and in many countries mainly mass spectrometry. So if you look at the simplest type of mass spectrometry with ecstasy, MDMA, we can expect it after extraction in the mass spectrometry with electron impact destruction. We expected some fragments, and these ion fragments, main ion mass, ratio mass to M to Z value. So it's ions, positive ions, characteristic for MDMA. So we have the this pattern of ions in a real sample, and if this pattern matched to spectra. In library, we can see that it's probably very high confirmation with the very high similarity of the spectra, and we can say, okay, this is the MDMA. Of course, we should also inject the MDMA standard just to also prove with the retention time chromatographically, which is a real also confirmation with the standard injected. If you look at the same MDMA ecstasy and UV spectra, it's not so characteristic because this is maximum or minimum, but these two maximas, 234 nanometers or 285 nanometers, these maximas for absorbance and for UV related to MDMA, these maximas you can find for many others substances. So it's not so characteristic like fingerprint, mass spectrometry fingerprint. Okay, maybe small break. What do you think? So now I started with the more cases, and I will be closer to the reality. And at the beginning, I start with the politicians. So if you look at the history of the criminal poisoning, we see that different type of the poisoning in the political world. So we have the Georgy Markov, which we have ricin, and it was quite sophisticated method for the murder of Georgy Markov. He was a Bulgarian dissident, and he was killed by poisoned by a ball, which is hidden in the umbrella. And inside, later they found in the this bullet, they found ricin. So he died after 3 days. So at the beginning of the poisoning, he didn't mention that he had a small hole in his body. It was very small, really, bullet with the ricin. Another type of the this kind of the poisoning in the political world, it's Khalid Mashal, head of Palestinian Hama, and in his case it was the fentanyl opioid drug injected or spread. We don't know exactly, but it's a way of poisoning. It's related to the putting in his air, and at the behest of the Jordan's King's Israel, he provided antidotes. So from Israeli politician, he received the possibility to find an antidote, and he recovered, and he was alive in that case. Another type of the poisoning, this criminal poisoning with dioxin, it's Viktor Yushchenko, candidate for president of Ukraine, and in his case, he received dioxins, TCDD, dioxin during the supper in the salad. It was the dioxins inside, and he had a quite strange face after this poisoning. He survived, and this toxic substance was determined and checked in the, I don't remember, I think it was in the Austrian laboratory. Another different type of the criminal poisoning was Alexander Litvinenko, and this is a Russian spy, and he was involved in this criminal intoxication with polonium-210, so radioactive isotope. And of course, this is unusual. way of intoxication and poisoning, and he died in the hospital 3 weeks later. Kim Jong-nam, it's a stepbrother of South Korean leader, and here we got that nervous system, so organophosphate agent, chemical weapon, and this VX substance which act on the central nervous system and introduce the he was attacked by the women with the tissues. They put tissues with the VX, soaked VX in these tissues on his face. And just a few seconds, it was enough in the Lumpur airport to have this contact with the VX to die later in the hospital. So it was not so huge dose of the VX weapon. Sergei Skripal, Russian double agent, and in his case we have the Novichok the first time, and Novichok it's also organophosphate pesticides or weapon which is similar to VX. And in his case, he survived. He survived, and his also daughter. After many weeks, they left hospital. And one of the latest, Alexei Navalny, he was also treated with the Novichok, so this organophosphate. And he survived, as we know, and he was back later in the Russia, and now it's in the prison. So now I will switch to the cases, and based on these cases, I will try to explain some real problems related to our job. So we have, let's say, one of the biggest case from the last years. It was the case with new psychoactive substance 25B and BOMI and cathinone, synthetic cathinone, clefedron. So it's started in the scene was 2014. 7 years ago, about 10:30 p.m. So it started from the jumping out from the window. One guy jumped out from this 5th floor, and the police came to the scene with the first victim. In that case, so 20-year-old man who jumped out from the window, but when the police and medical doctors came into the scene, they found on the 5th floor 2 other men, young men, and one of them died in the way to the hospital. So it's just 2 hours after the first case of the fatal case. And the third man, 24-year-old man, survived. So during the police action, during the time of the intoxication, when the police came into the flat on the 5th floor, they found 2 young men, which were aggressive, were agitated, shouting at each other, screaming, speaking illogically, not reacting to any orders. And one guy, as I told you, when they came out from the flat during the route to the hospital, he died. He had strong convulsions, heavy breathing, and salivation. So if you look at the results with the screening methods in that case, for these subjects, we have the ELISA test for the classical drugs. So we have the positive results for subject 1 and 3 with cannabinoids. So they smoke marijuana before this case. They also drink alcohol. So in urine we found alcohol, and also we have the positive results for. So the first one was blood, and urine also give us the metabolites of cannabinoids. So again, it's a positive results for marijuana smoking. So we use for blood and urine different methods. So untargeted identification and targeted. With untargeted identification, we use liquid extraction, and with it's based on the special sorbent, and this liquid extraction. After that, we have the possibility to analyze with gas chromatography, mass spectrometry in scan mode. So we can compare this result with the database. And another route, it's also liquid extraction with protein precipitation. And after centrifugation and dilution, we can possibility to use the untargeted liquid chromatography with time of flight mass spectrometry, and based on the mass, determined mass, exactly mass, we can also estimate or identify roughly the substances. But also we use targeted methods for quantification. So also liquid extraction with ethyl acetate, and after acidation of environment, we can and evaporation, we can reconstitute with the mobile phase, and again liquid chromatography with tandem mass spectrometry. But this is targeted, so we know what we would like to find. Of course, it was a little bit easier because I didn't tell you, maybe it will be later, that on the scene we found also the labeled of the seizures of 25B and BOMI and 4-CMC. So these new psychoactive drugs, they were bought by young people, and so we know what we expected. So this targeted analysis was easier for sure. So tandem mass spectrometry with the time of flight give us the opportunity to find 25B and BOMI, which is the related to phenylethylamine structure with the bromium inside. If you look at the 4-CMC, so it's a 4-chlorine metcathinone, so it's a synthetic cathinone structure. We found, let's say, also the traces of these substances, but you should know that, maybe you know that it's synthetic cathinones, it's very sensitive for degradation, and after taking samples, we expected very quick degradation. So it's not stable substance. Even if you put blood samples into the fridge, still it's a quite huge degradation. So it's better to keep samples in -20 degrees centigrade, or even better -80 degrees centigrade. But -20 it should be done in the case of synthetic cathinones. So if you look at the blood, 6 blood samples to check the interferences for the analysis, we look at these substances and look at the blank samples. So blank samples should give not any peaks for the 25B and BOMI or 4-CMC synthetic cathinone. So if we don't see any interferences, it's okay. So criteria, if you look at the validation of the methods, we try to find matrix effect. And this matrix effect, if you have the close to the 100%, it's a no matrix effect. If you have the less, it's a suppression of signal. If you have the more than 100%, it's ionization enhancement. So we try to find also and check matrix effect. Linearity, it should be around 0.99. It will be the best. So here is a result for 25B and BOM. It is phenylethylamine analog, bromium analog. And interdate precision should be not exceed 20%. It will be between 1.7 till 12.2%. If you have trueness recovery, of course, should be around 100%. Yeah, it's here mentioned close to 100%, and variability 15% of the variance. Limit of detection and limit of quantification, it's of course depends on the way of establishing limit of detection or quantification, but usually we use this formula with the standard deviation of the intercept for the blank samples, and 3 times LOD, it's estimation of limit of quantification. So results for clefedron for CMC, it's the same criteria, and the results, it's fulfill this criteria. Of course, matrix effect is here lower than 100%, so it means that we have the suppression of the signal by co-extracted compounds included in the matrix. Linearity is quite nice. Interday precision still is close to 100%. Trueness also, and limit of detection or quantification should be okay for our purpose. So this is the results of these 3 cases, these subjects. So if you look at the 25B and BOMI, we have the subject which jumped out from the window. We have the 66.5 nanograms per milliliter. It's quite high concentration in the blood. Subject who died in the way to the hospital, we have 10 times more, 661 nanograms, and a guy who survived in time. We have 2 results, and it was the decreasing tendency. It means that between 0.30 midnight and at 9:50, at that time between 0.30 midnight and 9:50, what was the metabolism status? What was the status here if you look at these results? It was absorption or it was the elimination phase? What do you think? What phase? Yes, elimination phase. I try to read in Russian, but it's of course not so easy for me. Many years ago, I tried to learn Russian. No problem. Try to use English because I don't use Russian many years. Elimination, yes, it looks like elimination phase. In urine, of course, we also can find quantitatively results, but it's not so easy to interpret. And we have the stomach content, quite huge stomach content concentration for subject number 1 and number 2. So fatalities is very high stomach content. These young people, the third person described with the way of the preparation of the 1025B and BOMI drug. So they dilute 25B and BOMI in the water, and they they split this dose for 3 people with the syringe. But as you see, maybe they don't do it in the right proper way, because we have the quite different amounts. But of course, in different time they died. So the subject who jumped out at 10:30, different concentration than the guy who died midnight 30. So it's not so strange, because we have different time of metabolism. So yeah, if they take the same dose, we should take also into consideration the time window. So it's also important to have the interpretation in time. So clefedron 4-CMC synthetic cathinone. We have also the elimination phase. If you look at the blood in different time, as I told you before, THC and THC carboxylic acid, just information about the cannabis use, smoking marijuana, and drinking ethanol. So yeah, I switched to another. So it's just summarize these cases. So it was the first scientific report involving validation of this method, and we proved that they took the 25B bombing with the quite characteristic symptoms of 25B bombing action, psychoactive action with the psychosis and different illogically behavior. Another case, it's again 4-CMC. Just we have more than one case. We have 15 forensic cases related to clefedron, and we summarize these CMC cases. So if you look at the cathinone, we can find many synthetic cathinones, and one of them is 4-CMC 4-chloromethcathinone. And if you look at the chromatogram and also the sample for the blood, you see that it's let's say a selective method with the drug-free sample. And in the mass spectrometry, we expect the fragmentation because of the idea of the mass spectrometry. Usually we destroy the structure for the fragments, ionized fragments, and these ionized fragments we can find later in the mass spectra, usually positive ions, but also we can also monitor negative ions. And these cases of the fatal and non-fatal with clefedron 4-CMC, you can here see the symptoms. Sometimes it was the slurred speech, slowed behavior. Sometimes you have more information. It depends on the case. And here the patient was joyful, exhibit increased drive, tachycardia, dilated pupils, difficulty picking up objects from the ground. Again, slurred speech, dilated pupils with the poor light reflex, difficulty walking. And of course, some other substances we can also measure. So instead of the 4-CMC, we also can measure ecstasy here, alcohol, also marijuana, some benzodiazepines, so diazepam, amphetamine. Also, it's possible to find in that cases. So yeah, again, we can find, let's say, death. In that 5 fatal cases, we have the accidents, road accidents, and also again we can find alcohol and cannabis, which is the most common other drugs which people use, driver use in Poland and in Europe. Another fatal poisoning cases we can here describe. It's a mixture of GHB, ethanol, and cannabinoids, and this is quite special because one guy, after poisoning, they went to the hospital. After several hours of treatment, the patient displayed muscle jerks, tremor with bending movements. In view of difficulties with effective management of his tremor, the patient was put in the medically induced coma with thiopental, hyperthermia, which is quite characteristic for also the some kind of the poisoning with the GHB. Also, ethanol was measured here. The second and third and fourth day, the patient was still deeply unconscious. Signs of brain stem death. Also, it was cured. He was cured with barbiturates, so we also can measure barbiturates here, thiopental. And at fifth day, at 2:45 a.m., committee and adjudication committee, pronounced brain death, and and this guy died, and organs for transplantation was prepared. Here we got the curve for the determination. So we have the calibration curve in urine and blood. So the angle of the tangents of this curve indicate the matrix effect. So for the blood, we see that it's influence of the matrix for the angle of the calibration curve, but the linearity is okay. So if you look at this result for patient for blood and for urine, if you compare this guy, because this is the concentration of in blood after death, we have the after death. It was the 5 hours after the accident. So we have the blood and urine taken 5 hours after incident. So it's a quite low concentration. If you compare this result, 5 micrograms per milliliters, with the references. So we've got the literature references. How you can interpret these 5 micrograms per milliliters related to concentration in the literature for blood. In which region? Endogenous, non-toxic, toxic, or lethal? Yeah, it looks it's non-toxic, but yeah, we don't know exactly. The blood was taken maybe at 5 hours, maybe not. We don't have information about blood. I mentioned that we know that 5 hours, but no, in blood we didn't know about the time of taking the blood. We know only about the urine. But if you look at the urine, it's 3,000 micrograms per liter, and if we try to interpret with urine, and this it's lethal, yeah. If you look at the urine, we have the 3,000, which is more related to lethal concentration as a reference from papers. So yeah, based on the urine, we expected, let's say, high dose of GHB taken by this guy. Yeah, sometimes it's of course quite unusual exposure, like for toxic effects for chlorine. One case of toxic effects of chlorine we measure in the case which I describe in a moment. But if you look at the urine concentration chlorine concentration in air, we expected very quick action and death after several inhalation if you have the very high concentration, more than 1,000 ppm. So it's related to Haber's law, which I described in the first hour. This Haber's law gives us the very quick death lethal effect if you have the very high concentration. So of course, if you have less concentration, you have the less toxic effect. So if you have the, let's say, on the other hand, 1 to 3 ppm is only irritation of mucous membranes of the nose and mouth. So it's really related to the concentration of chlorine in the air. So more or less, it looks like, as I told you, Haber's law. So very high concentration and very high quick effect. And if you have the low concentration, this effect will be much longer. So chlorine is moderately soluble in water. And if you look at this solubility, it's decreases increasing in the of temperature. And maybe you know that during the summertime, we expected that fish died because of lack of oxygen during the high temperature during summertime in the water. So also here, the solubility of chlorine decreases with increasing of temperature. Also hydrolysis, we expected the hydrolysis of chlorine in water environment, in aqueous environment, and this creates hypochlorite ions. And this kind of reaction also occurs in the humid environment and in the human respiratory system after absorption of chlorine gas. So chlorine creates the acidic environment after let's say absorption in the respiratory system. So I didn't tell you that this guy who died with the exposure for chlorine, active chlorine, with the relatively moderate concentration of chlorine. Okay, quite strange and unusual death we also find with helium. And helium in the lungs, we measure with gas chromatography coupled with mass spectrometry, but it was not so easy because, as you maybe know, with gas chromatography, we usually use helium as a carrier gas. So we had to switch to another gas, not to helium, to detect helium. So in the papers, we can find different cases with helium because the people in the world, they use helium to commit suicide. And the idea of using helium as an inner gas is to reach the faster impact of lack of oxygen during inhalation with helium. So if you look at the sex, of course, gender is usually male, and usually the circumstances of death is related to the men who connect a helium source, helium gas, with the plastic bag over his head. So this is the, let's say, usually circumstances of the death. So usually we can find this guy with mask or with a plastic bag on his face. So in our case, also it was the man who committed suicide with helium, and this is helium in this tank with the used to the fulfill the balloons. So this analysis and these circumstances, of course, indicate the breathing helium, of course. So for the purpose of the analysis, we use the a little bit different than in the literature, because in the literature they use the lung tissue in the container when they use the possibility to collect bubbles of helium in the special type of the tube, we use the plastic bag and heating, a little bit heating for the liberated helium, and with syringe we take the bubble of the gases mixture into the injected into the gas chromatography with mass spectrometry analysis. So of course, that kind of the analysis, we expected that using the helium, it's let's say quite strange, but maybe not so sufficient, because still we, during the autopsy, we can find the drops of water inside the bag of the suicide victim. So it means that these guys live a little bit longer than they expected. I mean, several minutes. So it was not so painless death when they, if they think that it's maybe painless. Okay, so this is the something which I mentioned about the also code of ethics, and in the TIAFT, I think it's a quite important thing for young people, for you, to have the code of ethics, because in the organization of forensic toxicologists, we agreed to provide our measurements, our experiments in professional manner, and following the ethical principles. And of course, it's important to follow this kind of the ethic codes, because in many cases, of course, we are later go to the court, and we have to prove that our experiments were done with the very high also ethics rules. So I recommend to, let's say, just follow different organization, and also it's possible to pick up these rules to the laboratory, not only related to forensic toxicology. So members agreed to perform professional activities in honesty, integrity, and objectivity. And objectivity, of course, it's something which we follow in each kind of experiments. So education, trainings, experience, certification, area of expertise, hold in confidence. So also provide expert advice and opinions within the limits of individual competence, and render of testimony in a truthful manner without bias or misinterpretation, refrain from exercising professional or personal conduct adverse to the best interest of the this toxicological organization. Okay, and now I would like to show you the some reports. Any questions, maybe? No question? So what would I would like to show you, it's a type of the movies which liquid chromatography and gas chromatography. Probably you know that kind of the movie, and just to remind you the way of the chromatography process. So if you look at the quite simplest determination, we can find, for example, column separation. If you look at the this kind of the separation, you see that on the top we put the substances, and during the liquid chromatography separation, column separation, we have the possibility to separation of the substances. Okay, the question is, in the meantime, what is the proper way to eliminate heavy gases from lungs? Heavy gases, what do you mean heavy gases? Helium? Okay, helium is a very, let's say, volatile compound. Volatile, maybe not compound, but volatile SF6. Yeah. Okay, it depends. The hyperventilation in the lungs. It's related to the. The lipophilic or hydrophilic properties, for example. So if you have the inert gas, because helium is inert gas, we expected that it's quite easy to get rid of the helium. SF6, I think it's a mixture. Yeah? Could you explain me SF6, because I don't remember what is SF6. Okay, sulfur hexafluoride. Okay, where is the use? It's used as an agent in the freezers. Okay, I should check it because I don't know. So I don't want to tell you not proper answer. So I should check it, and I can give you the answer later if you wish. Okay. So in the case of alcohol, I told you last week that with alcohol we can't get rid of alcohol, ethanol, so easy because it's a hydrophilic. With carbon monoxide, which I told you today, it's quite easy to hyperventilate our lungs. So of course, in the case of it depends on the properties of the substance. So it depends, of course. With helium, also sometimes they use nitrogen. Instead of helium, they use also nitrogen. And nitrogen also is an inert gas, and we know it's more related to the asphyxia, so lack of oxygen. And now I will continue with the chromatography. So just have a look at the separation process during the gas chromatography. Let's have a look at this kind of separation. So as you see here, it was the exactly separation, chromatographic separation of the analytes of different substances here. And of course, retention time, it's identification factor. And of course, the second is the specificity of the mass spectra. Okay, so this is the idea of the gas chromatography with separation with gas. And maybe it's, of course, more interesting, let's say, this separation, I mean the report. Maybe I will show you the report from the newest one. I think that I have a European drug report, the new one. One moment, please. Moment. Okay, I think it's okay. Okay, so I think it's more or less finished. Have you got any questions? Maybe related to the first seminar, which we know that some of you didn't participate in the first seminar. Have you got any questions maybe to the first seminar? No questions? If there is something, let's say, unclear, or you don't have, let's say, now an idea in your mind, we can postpone this question later. So send me your email or your question via email, and I try to answer it during the time before, let's say, the tests you have. In the end, you've got the test of for these seminars. So let's say if you have any other question, please let me know and I will try to answer it. So thank you very much for your attention, and be in touch if you wish. Let's say, do it. Don't let's say be so shy and just ask me. Thank you again.